Alright, our new topic is complex numbers. Now the most important result that we have in complex numbers results from this equation that troubled mathematicians for a very long time. It was x squared equals -1. And the problem with this, of course, is that when you think about real numbers and you try and solve for x, take the square root of each side and you're going to end up with the square root of a negative number, which does not exist in R, or in the real numbers. So what they had to do is they had to come up with a new number system. Okay, and that new number system that they came up with, I'll just make that look a bit nicer, was the complex number system. Okay, and coming up with the symbol I. And where I comes from is that they've actually defined a solution for this equation, and they've called that I, so that I squared equals -1. What that means is they're actually, and formally, we should say, defined I to be equal to the square root of -1. So they're two really important expressions that we need to know for complex numbers. What that means now is that we're actually able to solve an equation like x squared equals -1. So for x squared equals -1, we actually find we have x equals plus or minus the square root of -1. And because -1, or the square root of -1, is I, the answer here is plus or minus I. So we actually have two answers for this equation here. So this complex number I allows us now to work with square roots of negative numbers, which we couldn't do before. Okay. The other important thing to understand with a complex number is that we write it with two parts, a real part and an imaginary part. So the form for a complex number is written, generally we use Z. Okay, so we call a complex number Z, and we'll just do this in red. A plus BI, okay, where we say that A is the real part of the number, and it's called the real part of the number because there's no I with the A, it's just a number, and B is the imaginary part of the number. It's imaginary because it's next to the I, it's the coefficient of I. Okay, an important result here as well, which I'll just do in another colour. If A equals 0, then we'd have Z equals BI, which is a purely imaginary number. Okay, there's no real parts to it. And also, if B equals 0, then Z will be just A. Okay, B equals 0. And that means that we actually have no imaginary parts. So this is a purely real number. And these are the numbers that we're used to dealing with. Okay, purely real as opposed to imaginary or purely imaginary. A and B can't both be 0. Well, they can, but then you just have Z equals 0, which is not a very interesting number. So when we're talking complex numbers, the other thing that you'll find with the expressions is real and imaginary parts, how to actually express them. So often, let's come up with an example. I'm just going to make up some numbers here. So let Z equal 3 plus 2i. You'll often find that you're asked for the imaginary part of Z. Okay, the imaginary part is the part that is with I, but it doesn't include I. It's only asking for B. Okay, the imaginary part of Z is just B, and so we can actually say here, this is really linked to the imaginary part of Z times I. So if we think about here the imaginary part of Z, that would be 2. Okay, the real part of Z, that's the part that doesn't have I with it, and here you can see that would be 3. So that's when we're talking about a purely real number. We use the RE for real, so that's the real part, and we use the IM for imaginary, that's the imaginary part. Very careful that you have no I here. Okay, you don't include I, just the coefficient. So you can also do algebra with these kind of expressions as well. So if you're asked for the imaginary part of Z plus the real part of Z, you can add those together. That would just be 2 plus 3, which is 5. So you can do algebra with these as well. The other thing that's important to know for complex numbers is that Z, and I'll just do this in red, Z is an element of the complex numbers, and we call that C. And what that means is, so Z is an element of the complex numbers. That covers all numbers that are of the form z equals a plus bi. So whenever you see a c coming up and they're talking about c, that's what that means. It refers to complex numbers. So the key thing to take out of this, the form for a complex number, z equals a plus bi, where a is the real part and where b is the imaginary part, that I squared equals -1, or just for me, I tend to just remember this one, I equals the square root of -1. That's going to be really, really important for us as we go through complex numbers to remember, because that helps us to simplify expressions with complex numbers.